Hello. Yes. We welcome you back to PSSB, Physical Sciences Silver Bullet, and it's me, Richard, here. Okay. Today we are looking at this question. It says that a stone of mass 20 grams is thrown vertically upwards from the ground with an initial velocity of 20 meters per second. The stone traveled till it reaches maximum height. What is the kinetic energy of the stone at maximum height? Okay, how do we go about this? We know that kinetic energy, which is Ek, is given by this expression. But we know something. We know that at maximum height, velocity is 0. So what does that mean? That Ek is going to be a half times m times 0, which is 0 joules. So at maximum height, the kinetic energy of the stone is 0 joules. So comes this question. It says that what is the gravitational energy of the stone on the ground? Okay, we have to know that gravitational potential energy is given by this equation. But you have to know that at the ground, h is 0. It is our point of reference where we start measuring height from, so it's 0. And so what does that mean? That EP is going to be mg times 0, which is 0 joules. So comes this question. It says that use the principle of conservation of energy to calculate maximum height reached by the stone. How do we go about this? So here, this is what we have to know. We have to know that if the stone moved this height, like this is the bottom, this is the top, and assuming that this is the height it covered, then we can say that the total mechanical energy at B, or bottom, is equal to the total mechanical energy at the top. That is what the principle of conservation of mechanical energy says. So we can put it here and we say EMEC, meaning mechanical energy at bottom, is equal to EMEC, meaning mechanical energy at the top. So what is mechanical energy? We saw in the definition that mechanical energy is the sum of gravitational potential energy and kinetic energy. So what are you going to say here? You're going to say EP, meaning potential energy, at the bottom equals to EP at the top plus AK at the top. And what is EP bottom? It simply means the potential energy at the top given by AM mg bottom, and EK is given by a half mv bottom squared. Okay, this side, what do we have? The gravitational potential energy at the top, which is going to be mgh top plus a half mv, and this velocity is at top squared. So what do we do here? We substitute in what we know. You have to know that the mass is 20 grams, but our SI units is kilograms. So what do we do? It's going to be mass 20 divided by 1000. What do we get here? 0.02 kilograms. So what do? We substitute it here. It is going to be 0.02 times 9.8 times height at the bottom, which is 0, plus a half times mass, which is 0.02, times velocity at the bottom, which we know it was 20 squared, and we know the mass, which is 0.02 times 9.8 times height at the top, which we are looking for, plus a half times mass, which is 0.02 times velocity at the top, which is 0 squared. We all know that when the stone reaches maximum height, it attains the velocity of 0. So when we compute, this side we get 0 plus this side we have 4. Here we have 0.196h plus 0. So what is our next step? Next step is going to be h giving you 4 over 0.196. So there we are. It is 20.41 meters per second. Okay. Then comes this question. It says that calculate the work done by gravitational force between the ground and maximum height. Okay, how do you go about this? Here we can apply the general equation first. It says any work is equal to F delta x cos theta. But in this case, what are we considering? It is gravitational force. It requires a free body diagram. Whereas our stone is going upwards, it has only one force which is acting on it, and that force is gravitational force. There's no any other force, otherwise it would have been mentioned here. So if that is the case, it means this. It means that our force of consideration is gravitational force. It means that the angle between, because the body is going upwards, the angle between our gravitational force and displacement is 180 degrees. So when you come to substitute here, this is what you get. You get work done by gravitational force is equal to gravitational force delta x cos 180 degrees. Okay, you have also to know that gravitational force is equal to mg. So if that is the case, so you come here and say mg delta x cos 180 degrees. Do you know the mass? Yes, it is 0.02. G is known, it's 9.8. Delta x, we found it as 20.41. That was the height achieved. And cos 180 is -1. So what we get out of this one is going to be work done by gravitational force. So the answer is -4 joules. And now we know what negative implies. Negative implies that the work done by gravitational force reduces the energy of the stone. Yeah, so comes this question. It says that what is the net work done on the stone? Now I need to tell you that in a situation where you have only one force acting, the work done by that force is the net work done on the object. So for this stone of ours, there was only one force which was acting, and that force was the gravitational force. So the work done by gravitational force is the net work done on the object. So what is going to be the answer? The answer is going to be -4 joules. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet. See you next time. Don't forget to subscribe, to like, to comment, to share. We are simply the best. See you then. Bye-bye.